So here we are in our working example, and I would like to say that data file which we will try to analyze will be data file from World Internet Project. The shortage is only WIP, and this wave is from 2006. The reason why we are using this data is very simple. As Czech Republic participated in WIP 2006, 2007, and 2008, and I was one of coordinators of Czech collection of data. That's why I decided to take this data, for example. And I would make a brief introduction into data file itself. Then we will find, I would say, some problems with data conversion into GMOV from SPSS format. And that's why in the next step, we would convert data file from SPSS, not from SPSS, but from Microsoft Excel environment. So here it is. So first of all, I would open GMOV, and in GMOV, I will take the file in Microsoft in SPSS as the first, and then we will switch into Microsoft Excel version. So if you take the file which is called inet.sav, so file open in GMOV, or I can open it, or reopen it as it was opened on my computer previously. So you will find a data file which seems quite good for the first sight, but you will recognize that there are some troubles behind the scene. So first of all, I will describe data. I will say some comments about individual variables. We will discuss about our file model, and then we will try to find some problems, and we'll try to solve these. So first of all, I would like to introduce the first variable in this data set, which is called use, and this will be our dependent variable. And this is answer for the question whether somebody is using or not using the internet. Once again, data are, I would say, quite old one, 2006. And you should remember that in 2006, internet penetration, especially in households in the Czech Republic, was approximately slightly above 1/2. And it means also that approximately only slightly more than 1/2 of people use internet on something like a daily basis. So according to this information, it is expected that proportion of these use, yes or no, would be approximately 50-50. So that's the first information for you to have. And once again, this would be our dependent variable. And we will try to explain what are differences between those who are using and not using internet in these times. So it would be our main goal. And for these purposes, and I hope you can help me, we can take some predictors. And first of all, and the first variable in my data set is called age. And my question is whether age in 2006 should be somehow related to internet usage. And if yes, what could be the relationship? So some proposals. Is it age good predictor for using the internet or not?
Maybe younger respondents would have greater probability.
Younger would have higher probability. Yeah, definitely, I would agree. And especially if we studied articles which were published before this research. So there was big evidence that especially younger are more probable users. And of course, on the contrary, older people are not using internet at all. Okay, so that's about the age. Let's discuss possible impact of gender. Once again, 2006, should be there any difference or not, and why? And if yes, what would be the difference? Male or female, more probably users or non-users? So I know it's a long history, but I can say once again that according to studies that are present in these times, the discussion was mainly that slightly more users are among men than among women, and the main reason was based on, I would say, arguments from gender sociology, as there was discussion that there are more and more duties for women in current societies, and for male there are less duties, so that's why they have also time to spend time on some free time activities such as internet browsing, etc., etc. So this is predictor, which is maybe not so strong as the age, but maybe we can also incorporate this predictor. So currently, if you understand well to this first introduction into dataset, we are trying to inquire variables and to discuss theoretically what could be a relationship between individual predictors and dependent variables. Okay. Next one, predictor is called EDU, so it is very easy to guess that's about education. There are 4 categories of education here discussed, and once again, the question is whether there could be some relationship between education and internet usage.
I suppose the higher the education, the more likely to use the internet.
Okay. So especially those with tertiary and secondary education, with state living exam should be more probable users, vice versa. Okay, I would agree, and all studies all over the world in 2006 said nearly the same. So that's all. We can skip use. As we know, this dependent variable with yes, no options, coded, if I remember well, as 1 and 2. And then there is a set of related questions, DOM, DOM1, DOM2, and DOM3. And these variables, if I remember well, original wording in questionnaire were discussing whether, how many people in a household are in total. This was DOM1. Then DOM2 was number of people that are below 18. So it means kids or young people in a household. And the last one, DOM3, were people above 18. And my question is whether these 3 should be somehow incorporated or only some of these, and if these variables can somehow influence the using of the internet of the respondent, which is discussing about also his or her household. So some proposals. So if there are no proposals, I can give you a hint, at least once again from the literature. In these times, there was a big debate and also some empirical proofs that especially if there is a kid present in the household, so it means in DOM2 there is not 0, so at least 1 kid, then it is higher probability even for adult respondent who is present in the household to use the internet. So maybe it would be good to take DOM2 variable and to prepare binary variable from this DOM2 and then use it as predictor. For simplicity, we will skip this step. So that's why DOM1, DOM2, and DOM3 will be eliminated from our analysis, but it would be also possible to include at least DOM2 if we would create binary variable, would be maybe good predictor. Okay, last 2 variables. And the next one is called FINC, and it's nothing more than shortage for family income. So it is somehow categorized family income if you double click into this variable. So I guess you can find description that the first code is less than 8,000 Czech crowns, and the last one, which is number 15, is 50,000 and more. And then there is DK for code 99. So we have approximately 15 categories. So it is still ordinal variable, but nearly cardinal, I would say. And my question is whether family income or something like indirect measure of social status of the household can somehow influence or influenced in the history of the Czech Republic the usage of the internet? And if yes, what would be the influence?
I suppose, again, higher the income, the more likely to use the internet.
Yeah, higher income usually was the cause for higher penetration of the internet itself. As if you can imagine, and I know it's in your childhood, there was no coverage of all Czech cities and villages in 2006, especially by something what was called broadband. So it means a quicker version of the internet. And especially in small villages, there was no access at all. So it was no possibility. So at least there was some differences based on regions. And also there are some educational differences in these regions. And that's why it is somehow influenced. And last one item, and it is closely related to this discussion, is the size of the city or village. Once again, categorical variable. The first category is the village which is lower than 1,000 of inhabitants. Last one category, which is number 6, is more than 90,000. So it means some biggest cities in the Czech Republic. And once again, especially distribution of quick internet access was very, very unequal in these times. So that's why it would be good to include this variable. So that's the first intro of the data itself. And you can recognize very simply, and once again, that's not a very fantastic property of GMOV, that all these predictors are automatically, don't ask me why is it so, defined as ordinal. But it is slightly strange, I would say, that for gender, okay, it could be treated as ordinal, but maybe better would be nominal. For education, ordinal would be correct. For usage, maybe nominal also would be better. But for DOM1, DOM2, and DOM3, which are real figures, there are no labels behind, I would expect that it would be defined in GMOV as a cardinal variable. But you can see that somehow automatically, I don't know what the dialog is behind, it is currently defined as ordinal variable. The same property for family income is correct. It's ordinal variable. Only, I would say, it's a pity. That's the big difference between GMOV and JESP, that GMOV is not recognizing from a SPSS data file definition of missing values. So, for example, for family income, there is originally, if I remember well, defined 99 DK as user missing value. But here, there is no definition at all. So we should prepare this definition here in GMOV directly. And size is maybe also ordinal. But once again, it's quite strange that, for example, age is correctly recognized as cardinal, but DOM1, DOM2, and DOM3 are not. So maybe there is some predefined rule that if there are more than 6, 10 categories, so take it as ordinal, and if there are more, take it as cardinal, but that's not very good. And also the property for these variables and behavior for these variables is not also very nice according to my opinion. So let's check very simply, for example, this use variable as only descriptive statistic. So I would take descriptives for the use. Here it is. And if I ask for frequency table, I can find yes and no. So it seems correct for the first inside. I can also, for example, check gender variable as the next one. So it seems also okay, male and female. And now let's try to prepare some logistic regression model for these variables. So I would go into regression, logistic regression, and 2 outcomes only, users versus non-users. So binomial regression, and I would take use as dependent variable. And I would take also gender as the first independent variable, and I must decide whether it is covariate or factor, so it is factor. And it seems there is some problem. That's the problem which I announced at the beginning, that gender is treated as some unordered factor. That's a technical name from our language, I mean our programming language. And GMOV is not capable to compute this variable. So maybe, and that was my first idea, that I could change this problem if I take the gender variable and I would redefine this variable as nominal only. So let's go back to data itself, and I would go back to variable for gender. So here it is, and I would redefine this variable as nominal. And you can see that still, I would say this small trick will not help, as it is currently defined as nominal, but still there is some warning about free level only for unordered factors. And if you would try different variables that are present currently, and that's the problem, according to my opinion, for introduction of SPSS data that are automatically defined as so-called unordered factors by this procedure which is behind the scene, which is originally from R, that it will recognize badly the properties of these variables, and they are not possible to use directly in GMOV. So that's why currently I will not use this data file from SPSS, and that's why I will use a data file which is originally prepared in Microsoft Excel environment. So I would once again click into opening data file, and instead of inet SAV, I will open inet XLSX once again, which is also available for you in SIS. So here it is, and I guess the data file should be nearly the same, but only, I will close the previous one. Currently, there are no labels, as it is raw data file.
Sorry for disturbing, but I cannot see the XS file in SIS. Does anyone else have this problem?
You cannot find the file in SIS?
Yes.
Is it available in SIS?
Yes, I have the one.
Yeah. It should be available. It means in SIS, in the subject JSM 010 or JSB 526, which is our course. So if you subscribe to SIS, you should find the file. If you cannot find the file, so maybe I can go back to Zoom and send it into chat. So wait a minute. For simplicity, I guess it would work. So I would open the chat and I will try to show the file by chat. So currently it should be available via chat in Zoom. Is it okay? Can you see it? Okay, so I hope it works. Okay, let's go back. Here we can see once again the set of variables, but here we have only code, so there are no descriptions behind. If you would like to add some labels, it's possible, but it would be quite time consuming that you would need to click to every variable and to define individual levels description. So it's possible, but it's not maybe necessary for this first introduction. So I will close this dialog and we can only check the properties for the variable. So age is defined as cardinal, correct. Gender defined as nominal, correct. EDU defined as nominal for the purpose of logistic regression, that's correct, as we need to prepare dummy variables, so it seems correct. Use versus non-use, once again nominal, seems correct. DOM1, DOM2, DOM3 should be defined as cardinal, so we should redefine, but once again, we will not work with these, so I will skip it. And family income, once again, it could be defined as nominal, but as there would be from 15 categories, 14 dummies, I would propose to treat it as cardinal, as it is quite long scale. So I would click into family income, and we would take this variable as continuous in the logic of Gemovie. And I would only, once again, if you go back into these categories, 1, 2, 3, 4, 5, up to 15, so these are real incomes, but 99 is DKNA, so we should also exclude 99 from our computation. So I would click into scale or continuous, and I would also assign new missing value, which is 99. So it means those who didn't answer will be omitted from the analysis. So that's user missing value definition in Gemovie. So here we are. So I hope it is defined. Once again, 99. That's it. So here it is. You can recognize these missing values. So these 99s are currently shadow in data matrix. And last one, variable size. Once again, we can treat it as nominal, as we have 6 categories, or if you would like to have maybe slightly more simple outputs, so it means do not include 5 dummies, you can define it also as continuous for simplicity. So that's the decision that you can balance. So maybe we can, for simplicity for today, take the size also as continuous to have only one coefficient, which will be describing differences for individual city sizes. So that's all. So currently, that's preparation of data matrix. Once again, the biggest change is that 99 from family income was excluded. And it means also, if you can see the data matrix, that quite a lot of cases will be excluded from the analysis itself. As for those who have 99 for family income, for logistic regression will not be computed. So we will lose something like maybe 400 or 450 cases from the analysis itself if we include family income. Okay, so that's the first insight. And I would propose that the first model we will be applying by logistic regression will be model for usage. And the first independent variable will be the age. So we will repeat discussion about the interpretation of the coefficient in logit, about the coefficient in odds, and next steps will be to add some more variables. So here we are, and I hope that this, I would say, small trick, so it means to use data in Microsoft Excel format instead of SPSS format, will help us. So let's go into regression. Logistic regression, 2 outcomes, so it means binomial or binary logistic regression model. So here we are. I will make only this dialog slightly bigger. Dependent variable is use, and independent variable is family income. I must say before, age, before I start this dialogue, that it is quite strange in Gemovie also that if I will only apply dependent variable, there are no results, as there should be a result for the model of the only intercept currently, according to statistical knowledge, but Gemovie ignore this so-called intercept only model. In JASP or in SPSS, it would be included also this intercept only model. Gemovie will not provide results for this model. So if there are no predictors, Gemovie will not work generally in a regression model. So that's slightly strange, but that's the property of Gemovie. So I will include age. It's covariate. It means continuous predictor. So I can include it. And currently, I can see results. And before I start maybe to interpret results, but we know that we expect that older people are maybe more probably non-users and younger people are more probably users. But before I start this discussion about substantive interpretation, we know that there is a special part of this dialogue, which is called reference levels. And you can see that here for use variable, reference level is 1. So what does it mean? It means that currently we are not modeling usage of the internet, but non-usage in comparison with usage. So the dependent variable or left-hand side of a logistic regression equation would be logarithm of probability not use internet divided by probability to use the internet. If we would like to change it, and maybe we can switch it for the next time, we should click here and change the reference level here. So if I would change it, so you can see the change currently, the coefficient for the H is positive. So it means that higher, older people, more probably non-users. And if I would change it, it would be the same coefficient but with minus sign, and it means that the older you are, the lower the probability to be users. So once again, you can change these reference levels and you should change the interpretation. I guess that's very easy. So for simplicity, I will start with modeling of non-users at the beginning, and maybe we will switch for the next model, this reference level to non-usage. So that's about reference level. And we are mainly interested in some substantive results. So that's why I will try to describe these two tables. So first of all, here we have some basic description in this first table called model fit measures, which is describing, okay, here we have some explained changes in dependent variable. Once again, it's not explained variance, as our dependent variable has only two categories. So there is no real analogy to classical R-squared. That's why we call this pseudo R-square. We know that this is a McFadden R-square or pseudo R-square. If we would like to use maybe better, we can go into model fit and ask instead of McFadden or together also for Nagelkerke, which is the most common, and you can see the value, which is approximately 0.4. This is quite promising. This is quite big value, and it means also substantively that age is maybe quite substantive predictor for internet usage in 2006 in Czech Republic. So that's the first introduction into this discussion. And here we have some results, which is rough estimate 0.07. Once again, it is measured in units that are called logits. So once again, this logarithm of odds ratio. And once again, we usually do not interpret these values itself. Only plus means that if predictor is increasing, probability or also odd of dependent variable is also increasing. So here, this positive value means that the higher the age, the higher the odd or probability of non-using the internet. So that's easy and straightforward interpretation. But we know that for substantive interpretation, we mostly prefer to compute odds ratios. And once again, it is necessary to take this estimate in logits and exponentiate. Fortunately, Gemovi will do it for us. So I would click into model coefficients. And here I would ask for odds ratio. And I would get new one and plus one column in this model coefficient table. And here it is 1.0785, etc. So I will slightly round up. So it is approximately 1.1. And what does it mean? So if my age will increase by 1 unit, so it means by 1 year, my, once again, not probability, but odds, and odd means, once again, probability to non-use versus probability to use. So my odd to non-use the internet would be 1.1 times higher in comparison with those who are 1 year younger. So that's the interpretation of this. I would once again repeat, exponentiated the value of the estimate or exponentiated value of logit. Once again, we would need maybe for interpretation to take some bigger difference than 1 year only. So 1 year is maybe not enough. And last time we discussed on tightening data, if I remember well, about something like shift by 20 years, 30 years. So it means about 1 generation change. So we can take, once again, this rough estimate, logit, and make 30 times higher, and then exponentiate, for example, in Microsoft Excel or through ordinary calculator. Or another possibility is to take odds ratio. So it means this 1.1 or precisely 1.078, etc. And take the power of 30 if you would like to have change for 30 years. So for simplicity, I would take this table and copy into Microsoft Excel environment. And we will try to discuss about changes that are caused by 30 years. So it means differences for 2 generations. So first of all, I would take this odds ratio. So I would take this value, and I would take power of the 30, as currently generations are maybe changing after approximately 30 years, according to demographic data in the Czech Republic. I would need only to change, sorry, point by another decimal separator. And currently we can see the value approximately 10. So what does it mean? If I'm comparing people from 2 different generations, their odds to use or not use the internet are approximately 10 times higher or lower. If I'm discussing about comparison of older versus younger, 10 times higher the odd to non-use. And if I'm discussing about younger versus older, I can say that 10 times higher odds to be users. So it would be the possible interpretation for both sides of this value, approximately 10. And once again, warning, 10 is the value which is correctly only for my data. So it means here I have some sample of approximately 1,000 and approximately 400 people, if I remember well. And if I would like to generalize these results to the whole population, I would need to take confidence interval for odds ratio. So I would need once again to go into model coefficients, ask for confidence interval, and I would get 2 new columns here in the table, which is lower and upper confidence interval. For simplicity, I would once again copy this table. I would once again copy this table in Microsoft Excel environment. And here it is. I would need once again only to change a decimal separator. So here it is, first one. And here it is, the second one. And I would once again need to take from this 95% confidence interval power of 30. So once again, I would take lower confidence interval for odds ratio and take power of 30. It will be my first figure, and the same for upper. And once again, if my original result was that odds ratio is approximately 10, once again, this is valid for my data. So for the whole population, according to rough estimate by confidence interval, it could be somewhere between 7.5 and 12. According to my opinion, these are quite big values. From so substantive point of view, these are quite important results. So it means that differences caused by age, once again in 2006, were quite big one. It would be my final conclusion. And once again, this tool, so it means odds ratio and also confidence interval for odds ratio by this, for example, power of 30. So once again, I am trying to inquire change caused by 1 generation is quite a huge figure. So that's all for this, I would say, brief introduction of first variable, which is cardinal variable. So if my cardinal variable would be with quite, I would say, short scale, I would be using original odds ratio and its confidence interval for interpretation. But if there is long scale, such as for the age, maybe it is much better to take more units than only one unit, and I would need somehow to recompute original odds ratio. I hope it's clear. Okay, so that was the first model. And for the next model, I would go back to data matrix. I would like to add some predictors that would be nominal. And once again, maybe that Gemovi will create for us dummy variables. And all possible variables that could be applied into our model are gender, education. So gender is very easy. It would create only one dummy. EDU, originally 4 categories, so 3 dummy variables will be created. Once again, we will skip DOM variables. And last 2 variables for simplicity we define as continuous or cardinal. So that's why for these there will be no dummies and only one coefficient, nearly the same as for the age. So here we are, and I can go once again into regression, logistic regression. 2 binary outcomes, and I can apply new model. So first of all, I will ask for dependent variable, once again use, and independence. So continuous or by this dialog called coeficientts, age, family income, and also the size of the city. And first of all, I would ask also for Nagelkerke R-square. And currently you can see that original model with the age only have Nagelkerke R-square approximately 0.38. Currently, it is not even so big figure by this comparison. It is only 0.4. So maybe that 2 new predictors, family income and size, are not perfect for this explanation. And 2 more variables we will include gender, but it's necessary to define as factor. And I would also take education. So once again, automatically Gemovi for us will create 3 dummy variables as we have originally 4 categories of education. So here we are. We have, I would say, quite complex model. And final result for this model, Nagelkerke R-square is nearly 1/2. I must say that it is not very poor results from analytical point of view, but once again, do not mix it with the interpretation that 50% of variance is explained. It is defined by different computation, but once again, it's quite promising results. It's not nothing from a substantive point of view. And if I would take these figures, and that's my analytical recommendation, and you can see that for age, there is positive impact, for family income, negative, for size, negative, for education, for all these dummies, negative. So it is maybe much better to reverse coding or reference level of dependent variable, as all these minuses will become pluses. And once again, we will not be preparing model for non-usage, but model for usage. So my recommendation currently is, okay, let's switch reference level for dependent variable use as category 2. So this would be my first step. Let's go into reference level. And for use, I will change reference level as category 2. So we will be computing currently odds or logits of probability of using versus non-using. So that's maybe much better, as most of these coefficients would be above 0. And it also means that all odds ratios, so it means the next column, which you will create in a few seconds, will include values that are above 1. So it is much better for the interpretation. So I would go back And I would ask also for model coefficients, for odds ratio, and also for confidence interval for these odds ratios. So 3 new columns are present here currently in my table. So I guess we can skip the discussion about the interpretation of the age. Only currently the coefficient is negative, and that's why also odds ratio is below 1. So maybe that computational trick for the interpretation would be not only to take power of 30, but to take the inverse value of this odds ratio or 95% confidence interval. Let's go to the next variable, family income. Once again, this variable is quite long scale. If I remember well, originally 15 categories were included. So if I try to interpret results that are present here, so approximately 1.2, if I slightly round up, is the increasing odds ratio, which is caused by increase by family income by 1 category only. So it means those with higher income, as it was discussed previously, have the higher probability or higher odd. Here we are discussing about 1 point times higher odd to be users. Once again, odds to be user means probability to be user versus probability not to be user. So it seems that family income somehow influence this phenomenon. And if I would like to take maybe bigger difference, not only 2 categories that are close to each other by family income, but to take maybe 1/3 of family income difference. So I would take step by 5 categories. So I would take this value and will take 5th power of this value, once again, for example, in Microsoft Excel environment, and I would compute odds ratio for this change. For the size, this is nearly the same story, but this scale is shorter one. The size was in 6 categories, if I remember well. And you can see that estimate is very close to 0, and that's why odds ratio is also very close to 1. And you can also recognize here the pattern that p-value here for the size is even above 0.05, which is classical border for deciding whether effects are so-called statistical significant or insignificant. And it seems that size really doesn't matter. And now maybe the question is, okay, could it be really a true result that size of the city didn't influence internet usage in 2006? And I must reply very simply, probably not, but as family income and also education is somehow related to size, so that's why these 2 variables, I mean education and family income, somehow were stronger than size, and that's why the effect of size seems as there is no effect at all here in this. So if I would rephrase it by another words, well known for you from previous discussion about linear regression, maybe that size, family income, and education are somehow correlated. So maybe there is some multicollinearity in my model, and maybe I should decide whether some of these variables should be omitted from the model. I expect that if I would compute the model, which would be including only size, the effect of the size would be higher. So that's classical, I would say, appearance of multicollinearity of my data. Let's check it alone, please. And now we are following next results. So it means for gender, you can see here is comparison 2 to 1. If I remember the original coding in data, code 2 was for female and code 1 for male. So currently we are comparing female to male. And as it is minus here, so it means that for my data, it seems that there are more non-users for female than for male. So it is according to our previous expectation that maybe women spend some time on some other duties than free time activities such as internet browsing, etc. And the odds ratio is 0.7. If I would like maybe for simplicity to take not a value below 1 or not to have a negative value of rough estimate in logits, I can once again go into reference levels and I can change the coding of gender, and reference level will not be code 1, male, but code 2, female. And currently, you can see only very quickly recomputed results. So the same estimate, only instead of minus, there is plus. And you can see also inverse value for the odds ratio. Originally, it was approximately 0.7. And currently, 1 divided 0.7 is approximately 1.4. So my, I would say, very easy and straightforward interpretation here would be that for male, odd, once again, odd means probability to use versus non-use the internet is 1.4 times higher. But be careful, as you can see, next 2 columns for confidence interval, which are saying slightly different story. It could be nearly the same, so it means equal odds for both genders, and it can be also as high as 0.9. So this result, I would say, is slightly unreliable. So it means that maybe there are some bigger differences between male and female, and maybe there are nearly no differences at all. Still, according to p-value, it seems there is some difference, but maybe it's not very big from substantive point of view. So that's for gender. And last one, part of this table, and we are nearly at the end, and then we would switch into a SPSS environment for a quick introduction of the same task. So we are comparing second category, which is secondary education without state leaving exam to elementary, which is code 1. Code 3 is secondary education with state leaving exam, so it means you can go to the university. And the last one is university education versus elementary education. So these 3 comparisons are present here. Of course, if you would like to have different comparisons, you can change also by reference levels, reference level for education. But as all of these estimates are positive, and it means that odds ratios are above 1, I would take these values for the interpretation, as it would be very easy and straightforward to take these. So first of all, secondary without state leaving exam versus elementary 1.2. So it means 1.2 times higher odd to be users. So in other words, more probable is that somebody with secondary education without state leaving exam will be using internet than for somebody with elementary education. But 1.2 is not very big value, and you can see very, very big or wide confidence interval here, including value 1. And that's why p-value is above 0.05. So maybe there is no difference at all between these 2 groups. It is saying if you try to interpret p-value or confidence interval itself. So if p-value is above 0.05 or confidence interval for odds ratio is including 1, so it means maybe there is no effect at all. So 3 to 1. So once again, quite impressive results, 5.2. So it seems, okay, that's huge difference between those who acquired at least secondary with state leaving exam education in comparison with elementary, but once again, quite wide confidence interval here. But still, big difference, it seems, 3 times or 8 times higher odd for those with secondary education with state leaving exam. And the last one, which is discussing about university educated and those who acquired only elementary education, 6.1, that's estimate for my data, and estimate based on confidence interval for the whole population 3 times, or maybe even at the extreme 12 times higher odd. So it seems that there are some differences. And my question is currently, if I would like, for example, to compare the first category and the second category, so it means university educated and those who acquired secondary education with state leaving exam, how I would compute odds ratio for these two categories. Is it possible to use these figures somehow for odds ratios? We discussed the same problem in tightening data, if you remember well from previous lecture. So some hints how I can compute odds ratio for fourth and the second category for education. So you will take only odds ratio for the first category and divide by odds ratio for the second category. So 6.1 divided 1.2, and you would get odds ratio for this comparison. Of course, if you would like, Gemovi will compute for you. So you will change this reference level to the second category. That's also possible. You can check it. And 41 is 5. So I guess it works. So that's possible. And here we are. So we know about, I would say, all possible interpretations and also data preparations in Gemovi for binary logistic regression. I will only very quickly go through the rest of the dialogue, but I guess we didn't miss anything important. We will discuss briefly about some predictive measures next time more, but today I will only briefly go into this classification table for predictive measures. So here it is. As it is, I would say, very common instrument, how we can evaluate the quality of our logistic regression model. So what is included in this, simply we can call it contingency table, which is usually called as classification table. So if you discuss about classification table in logistic regression, you would get usually this table. You will see in a few minutes in SPSS environment that sometimes this table can be also slightly more difficult. There would be more figures here, but still what we have here. So individual rows are created by real status. So it means 2 and 1 means whether the respondent is non-using, that's code 2, or using, that's code 1. So that's my observed value. So it means if I would go into this table, I would find 440 non-users and 128 users, etc., and all the rest in my data. Of course, I'm currently excluding in this table those who didn't reply to some answer, especially those who didn't answer about their family income. So they are not included in this table. So that's about observed values, non-users and users. I guess that these values are closer if I would sum up these two rows. And here we have prediction from my logistic regression model. What does it mean? I would take these coefficients, so it means intercept, age, family income, size, etc. And I would take classical equation, which is logit of probability of using versus probability of non-using is equal to the intercept plus the impact of age plus the impact of family income. And for every respondent, I can evaluate probability whether he or she is using the internet. It would be my final result. We will learn more next time how we can compute this somewhere outside of the statistical software package. So we will be using once again Microsoft Excel. So you can compute the probability, and probability must be from 0 up to 1. And by this classification table, at least by default, it is predicted that if your probability to be internet user will be 0.5, you will classify this respondent as non-user. And if the probability will be above 0.5, he or she will be classified as user. So that's the predicted classification, whether he or she, according to his or her values of predictors, could be non-user or user. That's predicted value. If you would like to take these predictions, here you can go into save and you can create these predicted values directly into the data. So that's option how we can compute these probabilities directly into my data matrix. And here I have 4 possible combinations. So here, 440 people are those who are non-users and correctly were classified as non-users. So here, my prediction is correct. For the 134 people, they are non-users, but I classify these as users. So I'm making mistake. And that's why here it is computed, so that's nothing more than raw percentage here, that 77, if I slightly round up, percent of all these cases that are non-users were correctly classified. So in classifying of those who are non-users, I was successful approximately at the level of 77%. Nearly the same story can be applied to those who are users. So for users, 441 correctly classified as users, but for 128, my classification wasn't correct. And final percentage of correct classification is 70.7.5, so nearly the same as for those who are non-users. And it is usually also present in this classification table that you will compute total overall percentage of correct classification. So you will take these 2 figures, sum up, and divided by the whole number of respondents included in the analysis. You will see in SPSS that classification table can provide these figures. So that's all for this introduction of binary logistic regression via Jamovi. Once again, be careful about conversion data from SPSS formats. Sometimes in Jamovi, it can cause problems. I must say, from my previous experience with JESP, JESP is much better in conversion of SPSS data. Don't ask me why, as these software packages started at the same level. So there is some small difference. Okay, I will currently open the same file, so it means SPSS data file directly in SPSS, and we will briefly introduce the dialog for binary logistic regression in SPSS. So here we are. Slight advantage is currently that our data are currently including individual labels, but we don't need these, at least for this first insight. For correct computation is necessary to define for family income missing value. So here it is. So I would click into missing and define code 99 as missing value for family income. It will be my first step. And for the rest, as SPSS is also differentiating covariates and variables that are called factors, the same in Jamovi. So I would need to take age scale, that's correct. Gender should be defined as nominal, ideally. Education also should be defined as nominal. Usage should be defined as nominal. DOM 1, 2, 3 we will skip. And family income for simplicity and size we will take also a scale. So here it is, only change of measuring scale. In SPSS, especially for this procedure of logistic regression, it is always important to define correctly these measurement properties. So if you would like to find logistic regression, you would need to go into Analyze, Regression, and all logistic regressions are the second part of the dialog. First one is called binary. So it means if my dependent variable has only 2 categories, and there is also multinomial and ordinal model. We will go into some details of multinomial logistic model next time. So I would go into binary logistic, and if you see this dialog, you can see for simplicity that it is very close, but only SPSS is not in this dialog, and it will be slightly different for next time for multinomial logistic regression. Differentiating variables that are continuous or not. So in SPSS, there is only covariate dialog, but if some variable is nominal or ordinal, you can take the dialog, which is called here as categorical. So we will learn how to use it. So dependent variable, that's quite easy to take, is internet usage or use only. Here it is. And if I take independent, so age, family income, and city size, and the next set of independents will be gender and education. So I guess that currently the model is the same as for GEMOVI. If I go back and check it, so there was age, family income and size, gender and education. That's all. So here we are. And for the option categorical, I can define gender and education as categorical variables. So it means that here in logistic regression dialog in SPSS, SPSS will create dummy variables for us. So we don't need to create it ourselves in data. And you can see that by default in SPSS, and the same style is applied in GEMOVI and also in JASP, the first category of predictor will be defined as the reference one. So if I go back for education, it works. But maybe for gender, we decided to take class 1 category as the reference. So you would go into gender here for categorical covariates and change here last. And if you click here to continue, so currently all these are prepared for computation. For gender, last category, so it means female will be reference level, and for education, the first one, which is elementary education. So if you click into OK, I guess you would get 2 sets of results. And I would say the only weakness of SPSS, but it was also present previously in GEMOVI, is that currently we are modeling non-usage, not usage. How you can recognize this? You can go here into the table, which is called dependent variable encoding. And here you can find that yes is coded as 0 and no is coded as 1. And every time SPSS is modeling the category which is coded as 1 in comparison with 0. So if you would like to change it, you can see there is no magic tool such as here reference levels, and you can only click in GEMOVI and change reference level and change the computation. So if you would like to change it in SPSS, there is only one possible step. You would need to go into data matrix, and you would need to recode original variable for use. So I will do it very quickly. So I will go into transformation, recoding into the same variable for simplicity. So I would take use variable, and I will take original value 1, which will be still 1. So that's usage as the first condition, and original 2, non-usage, will be coded as 0. So lower category will be reference level for binary logistic regression. So I can click into continue. Okay, currently I should redefine labels. So 1 would be still yes, but 2 is currently not no option, but 0 is no. So I can remove this one label. And for simplicity, I can once again compute logistic regression. And currently, it seems that I would be comparing users versus non-users. You can see it here, dependent variable encoding, yes is 1 and no is 0. And I will not go into details, but here in SPSS, you can see 2 sets of computation. First one is called block 0, and then next one is block 1. This block 0 was totally missing in GEMOVI, and this is the description of the model in which there is no predictor at all. So if you go into this computation, there is only constant included here. So this is model for constant only. So I would say this is only for some comparison, whether predictors are good or not in general. So maybe we don't need this block at all, but that's the default output in SPSS. And here in the block called block 1, here we have a description of final results. And if I would like to make some comparison, so if I go back here in Chemovi, the first table in Chemovi was called model fit. There was some deviance, R-square McFadden, R-square Nagelkerke. Here you can see that there is also some model summary table. Here we have Cox and Snell R-square and Nagelkerke R-square. And the values must be the same, 0.482, Nagelkerke 0.482. So it seems that the computations are correct. Then by default in SPSS, you have classification table. So it will be also the same, I guess. So if you compare this original table, only these rows are reversed 2, 1. Here we have no and yes. So I guess that figures must be the same. Yeah. Also, these percentage correct are the same. And there is also overall percentage computed here. So that's classification table. And the most important table, as we know from previous discussion, would be variables in the equation. And if you would compare this table to the table computed by Chemovi, so it should be also the same. Only small difference, at least for the first insight, is that constant is the last one item as SPSS output. Here it is the first one item and called intercept in Chemovi, and here it is called as constant. And the rest is the same set of coefficients for age, family income, city size, etc. And you can see that by default, so there is no necessity to ask for these outputs. Here we have exponentiated coefficients. So once again, it is called as odds ratios here. So it is automatically computed in SPSS environment. So these are results, and I guess there is no need to interpret these results as we discussed about individual figures, so we can skip it. And here we have education 1, education 2, education 3. Be careful. It doesn't mean comparison of those who are elementary educated, category 1, category 2, those with secondary without, etc., and secondary with diploma. But 1 means this is the first dummy, which is comparing to the first category. So first one row is comparing those with elementary, those with secondary education without diploma, with those who didn't acquire education higher than elementary. Second one is the second dummy. So it means secondary with state leaving exam in comparison with those with elementary education and university education. So every time I would recommend you to go back. And here there is also the table, if I remember well, maybe I'm not sure, currently in the last version of SPSS. Yeah, here it is, categorical variables codings table, which is describing what is the first one, second one, and the third dummy. So first one is for those with secondary without state leaving exam. Second one is for those with secondary with state leaving exam, and the last one for tertiary educated people. So be careful about this coding table, which is describing coding of independence, and here we have coding of dependent variable. And if I go back briefly once again into logistic regression dialog, so there are many more options in SPSS. We discuss about categorical. You can also save quite a lot. If you go back into Chemovi, saving option is quite short one. Predicted values, so it means probabilities, residuals, and Cook's distance. In a SPSS environment, you can also save probabilities, you can also save Cook's distance, and you can save a lot of different residuals, and there are many more statistics here, such as, for example, DF betas, which we know can be applied if we would like to find influentials, and if we don't like to use Cook's distance. And there is also option to compute group membership. We will discuss about this option next time. So by option, you can ask also for some more outputs, And I would say the most important output, which was also acquired via Jamovi, is confidence interval for exponentiated coefficients for odds ratio. So if I ask for this output and I would recompute my results, I can take 2 new columns, which is 95% confidence interval for odds ratios currently here called as exponentiated coefficients. So these 2 last columns are the same as these 2 last columns in Jamovi. So it can be also found in SPSS environment. So if I conclude for today, I can say that analytical possibilities in logistic regression in SPSS and Jamovi are totally comparable. I can also say that analytical possibilities in JESP are neither the same. So it really doesn't matter which of these software packages you will take. Only we know from today that if you like to take some data file from SPSS into Jamovi and apply logistic regression, there can be some problems. So at least the import of the data from Jamovi is slightly complicated from SPSS format. I must say once again, in JESP, there are no such troubles currently. And don't ask me why, I'm not a producer of Jamovi, but be careful, and maybe that Microsoft Excel format can help. For the next time, we will briefly conclude discussion about binary logistic regression, and we will also skip to multinomial logistic regression. Once again, we will show how to compute it in JESP, in Jamovi, as well as in SPSS. In JESP, there is no such option still, so there is only binary logistic regression model included. And we will also start a discussion about the new topic next time. And last sentence from myself today is that next time we will start at 8:10, so it will be longer lecture. So that's all for today.